Hello everyone, welcome back. In this session I am going to take a working of the wind power plant. The wind power plant working we need to discuss on that one. Starting from the what is meant by wind and how it power is to be converted into a useful form, that is electricity. Then whatever this how the wind farm power is available in which form, all this we'll discuss in this session. Okay, going to this one, what is meant by wind first? We have to know that one. Wind is the motion of the air. So whatever the air is there around us, if it is moving, okay, then we'll call it as a wind. Then how the wind motion takes place? Here the heating and cooling of the earth surface and the water surface, and due to the heating of the earth surface from the different regions, that also cause the air to move. Okay, that taking the explanation of that wind means here consider to the sea surface and the earth surface. The sea is slowly get heated, then the earth surface, the earth will be heats quicker. Then as the earth is get heated, whatever the air is there above the earth, that will be heated and its density reduces. Then earlier that morning, okay, then water whatever is there, it is slowly get heats up to the afternoon. And then during that time, whatever the air is there above the water surface, that will be heated slowly, therefore the air density is more on the water surface. Then the air is flowing from the water surface to the earth surface morning up to the afternoon, and afternoon onwards the earth get cools quickly, and whatever the water is there, it slowly cools. Then later, then the earth surface is having the low temperature and air density, it will have the more. Then the water surface on that one, the air is there, it is having the density less. Then from the high density to the low density air flowing is taking place. On the earth surface also, if the hill stations are there, on the one side of the hill it will be get heated at the morning, and other side it will be get heated afternoon, and like that region, from the one region to the another region, the temperature of the air will be different, and thereby there will be, due to the temperature difference, the convection current will be starts. That is due to the flow of the air, that we'll call it flow of the air, that is taking place due to the density difference. That is the wind. And here the wind velocity varies from the region to the region, depending upon the whatever the geometrical conditions as well as the environmental conditions, it will be varies. And air flowing, we know that one, air is moving due to that temperature and the density difference. Then wind energy means what? If the air is moving, the air is a fluid, gaseous fluid, it is moving, then it will have the kinetic energy in it. Kinetic energy it will have. If the kinetic energy of that one, if you wish to convert into a mechanical energy, then that will call as a wind energy. The kinetic energy present in the moving air or a wind, okay, that will be converted into a mechanical energy, that is called as a wind energy. The wind energy can be converted by using some of the machines, and those are called as a windmills or a wind machines or wind turbines. Okay, here there are different types of the wind turbines are there, windmills are there, and those are mainly two types: horizontal axis wind turbine, that is called as a HWAT, and vertical axis wind turbine. Depending upon the air velocity, climatic condition, and what is their air velocity, distance from the earth surface above that one, based on that the type of the turbine we are going to use, but commonly we are going to use the horizontal axis wind turbine. Here the concern to the horizontal axis wind turbine, I will explain how the working is there, and vertical axis wind turbine, that can be taken later. Here wind turbine, this one, first we will take whatever the sketch is there in this one. The sketch in that one, this is the supporting for the wind turbine, and here are some arrangements to made for the installation of the conversion, and this wind rotors, or those are called as windmills also. And what are the parts are there? Wind turbine. First one is the blade. This is the blade of the wind turbine, and second is the hub where it is blades are connected. Third one is the pitch change. Okay, here the pitch whatever is there, the whatever moving out and moving in of this wind rotor are there, wind blades are there, those can be changed. That is the pitch change we can use. And fourth one is the mounting. Okay, it is together, the blade together, all these things have, okay, the pitch change all together mounted on this one particular element. That is a mounting, it is called. It's mounted on the shaft. Then it will be again the next one, it is a fifth one, nacelle. Okay, that nacelle whatever is there, it is the fifth support. The nacelle is the support for this. Nacelle is the housing for all the conversion mechanisms. This fifth one is this one. The conversion, whatever the components are there, first one is the gearbox, okay, then the turbine, okay, then whatever that yawing, that is changing the direction of the wind turbine. That all are housed inside this nacelle. Then sixth one is the pintle, which supports from this whatever tower with that nacelle is there. Then pintle and the drive, this one, okay, pintle and drive. Then seventh one is the tower, eighth one is foundation, and control building, ninth one. And here there are two parts, again it will be divided. A is the transmission, here transmission, B electrical. The transmission means here some of the couplings and gearings are used in order to change the velocity of the rotation. Usually rotation will be the 10 to 15 RPM, rotations per minute. It should be increased as per the requirement of the generator. Okay, then generator requirement, it will be increased and that will be used. And there is a particular range, within that only the generator works. Above that one it stops, and below that also it will drops. Okay, that will be there. Then here all this whatever we are explaining in the sketch, that we can explain in this photograph also. That this is a blade, this is a rotor, and this is a tower on which it will be mounted. The power cable which is carrying the power to the base, and here the gearing mechanism you can see, yaw drive, okay, that is in which direction the whatever the whole this nacelle is there, that will be rotates. Okay, then nacelle it is provided. And yaw motor, for that there is a separate motor is provided. This is generator, and this is a brake, okay, that will stops and put on that operation. This is the gear box, not to increase and decrease the speed. Nacelle, total housing for this one, all the components. This controller that controls the generation power. Okay, then anemometer, this measures the speed of the air. Anemometer is the device used to measure the speed of the air. Okay, this is about how the working of this wind turbine taking place. Okay, concerned to the horizontal axis wind turbine. And the power in the wind whatever is there, that can be measured in terms of the half rho V cube. Rho is the density of the air, area, soft area, that one, in which area the air flow is taking place, and V is the velocity of the air. By this one, if you know the density area over which the air is flowing, then velocity of the air, if you know the power how much is there in the wind, we can calculate, and that power can be extracted, not to have the mechanical power and the electrical power. That is explained here again. That is, wind turbine or wind generators use the power of the wind which they turn into electricity. The speed of the wind turns, the blades of the rotor between 10 to 25 turns per minute, that is RPM, a source of mechanical energy. Okay, that is a rotation whatever is there, it is a source of mechanical energy. The rotor then turns on a generator, and that converts the mechanical energy into electricity. If rotor turns the generator, the electricity will be generated. As the wind blows, a wind turbine converts the kinetic energy of the wind's motion into mechanical energy by the rotation of the rotor, and this mechanical energy is transmitted by the shaft to the generator through a gear train. Okay, this whole together, the transmission of that wind energy into that electricity, it is given. The generator converts this mechanical energy into electrical energy, thereby generating electricity. Like this, we can generate the electricity from the energy present in the wind into a electricity. Okay, then you can watch the other videos in which I will explain the other, that is the different types of the wind turbines. What are their concern to the only horizontal axis wind turbine I have explained here. The next I am going to explain other type of the turbines also. Okay, thanks for watching. Comment, share and subscribe my channel. Thank you.